If I have a string and I send a wave pulse down the string, where a wave pulse is just a kind of a chunk of wave where I go like this once and I send a wave down. Let's say it has an amplitude of A1 and it's moving to the right. And then I'm going to send another wave pulse in the opposite direction. It has an amplitude of A2. Now, the cool thing about waves is that when they go and they hit each other, they don't bounce off of each other. They don't change their speed or anything like that. All that happens is their amplitudes will add together. And this is called interference. So you get something like this, where this new amplitude is A1 plus A2. Now, at this point, the waves have combined, and probably before this, when they start combining, you get something like this, where this part of the wave is still moving right and this one's still moving left. You only combine like this for a brief moment. And then if you look again, you're going to then see them separating. So you're going to see the same kind of thing here with left and right. And then after, you'll see two pulses once again. But this time, this pulse is going to be the pulse that started on the left, and it's going to be moving right. And this one's going to be the pulse starting on the right that is moving left. So waves can pass right through each other. But if they do, they're going to interfere for a short time. The type of interference where the new amplitude is greater than the previous amplitude is called constructive interference. So this would be constructive interference. But you can also imagine a case where we have the opposite, where we have a wave here, and then we have a trough, a wave pulse there, which is a trough. And I'm going to, this time, let's say they have the same amplitude, A and A. When they hit each other, they're going to add together. When they add together, a trough pulse to crest, if the amplitudes are the same, they just go away. And then after a little bit, you can look again, and you'll see the two pulses have switched, with this one moving left and this one moving right. Originally, this was moving left and this was moving to the right. And this is called destructive interference. Destructive is when the amplitude from when they're combining, when they've interfered, is less than the amplitude either pulse started with. So 0 is certainly less than A. So that's destructive interference. You can also do this with entire waves. We can take a full wave, and we can line up all the crests with crests and the troughs with troughs. And if we do that, let's say we have a wave like this, and we add it to a wave, I'll add some more and make it more wavy, and you'll add it to a wave that is identical. That should be identical. I know I didn't do it perfectly. But here, all the crests add, so if we add these two together, all the troughs add, and you get something that has a larger amplitude, but you still get the same, I'm not good at trying this, you get the same period, you get the same frequency, you get the same velocity, everything's the same, the only thing that changes is the amplitude. That's what happens when waves interfere. Now, you can imagine that we could again do the opposite, and we could take this and shift it by half a wavelength. And when I say that, remember that a full wavelength is this. So if I shift it by half a wavelength, I'm going to be shifting it by this. So I'm going to take this and move it here. And if I do that, then I'm going to have my first wave, and then over here I'll have my second wave, which I've shifted, and which means now it looks like this. And when you add these two together, you just get nothing, because they cancel out completely. This is destructive interference again, this is constructive interference, but usually, you're going to have some kind of a mix of the two. For example, I have here two tuning forks, which make a C when hit. You can listen. C. This one also makes a C. Okay? But now I'm going to hit them both at the same time, and I want you to listen. I hope you'll be able to hear this on the video. going to do it again. One more time. Maybe one more time. I like doing this. What you should be able to hear is when I hit just one, it's a nice pure tone, just a single note. But if I hit two, you can hear a slight tremor, a slight beating, kind of a wah 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 wah. And why is this? These are both supposed to be C's. They should just add together and get a little bit louder. The reason for this is because if you have two waves that have slightly different frequencies, right? One of those tuning forks maybe is putting out a C. The other one is putting off something that's slightly off from a C. When tuning forks start to get old, they get a little bit chipped, and then they, maybe produce a slightly different note. So what I have is I have my C, and then I also have a wave that's slightly different frequency. Okay? And a slightly different frequency would mean you'd get something maybe like this, where at first they seem to be adding, but as time goes on, they don't. So here, constructive, still mostly constructive, kind of a mix. Oh, we're starting to cancel out, right? So what you get from this, and I'm not gonna directly add them because here you have a very large amplitude, then they start to cancel out. But if I was to do this for two waves, you're gonna get something that looks like this. Where you get a louder sound and then a smaller sound. Louder sound and smaller sound. Louder sound and smaller sound. You can see that. Here, this would be the loud sound because they're adding, and then it starts to shrink as they cancel out, and then it's going to start to grow again. So that's what causes that kind of a beating pattern. As it turns out, what's controlled by the amplitude is the loudness. Loudness of a sound is the amplitude. And you can really kind of visualize this if you pluck a guitar string. If you pluck it only a little bit, you make it so the amplitude of the wave you're making on the string is very small, then you're going to have a very small sound. But if you jam the guitar, you get huge amplitudes and you're going to have a very loud sound. Yeah, so amplitude controls that. Frequency controls that kind of note that you're hearing. And wavelength does the same thing because in this case, velocity through airs always has to be the same. So that is wave interference, constructive, destructive, this kind of cool beating thing. You get a lot of other patterns too, but these are probably the simplest and the ones that we're going to stick to in this class.